Okay, continuing with the Chapter 1 lectures, we're going to get on with talking about measurements of matter. Okay, so when we're talking about this type of thing, we are referring to numbers with units. Okay, so numbers without units are just abstract concepts. Okay, so when we apply a unit, say 1 centimeter or 1 pound or 15 cookies, we're applying some sort of unit that gives the number meaning. Okay, otherwise, like I said, it's just an abstract concept. Okay, and I want to make it clear that throughout this semester and pretty much any science course that you take, units always count. Okay, let me say that again. Units always count. Okay. Numbers without units don't mean anything, okay? And what we have are what we call SI units, which stands for, let me see if I can get this spelling correct, Système International National d'Unité. Okay? Which basically means International System of Units. Okay, so SI units, International System of Units, and they're all metric. Right, so everything's multiples of 10. So common base quantities, common SI units. Call them base units. We've got a bunch of them. One for length. The SI unit for length is the meter, lowercase m. For mass, we have the kilogram, which is kg. For time is the second, S. For temperature is Kelvin. For Lord Kelvin, capital K. For the amount of something is the mole, or MOL. For one of my personal favorites, electric current is the ampere, which is capital A. All right, ones that we're going to deal with most in this class: length, mass, sometimes time, temperature, and amount of things. I guess everything but the electric current. But anyways, so what we do is because everything's metric, we have prefixes. Okay, so prefixes, they tell you how much to multiply the base quantity by. Right, and I've got a lovely table here for you. Now, if we were in class together in person, you would have to memorize most of this table. Okay, I recommend memorizing it anyway, because you're not going to be in virtual learning for forever. Eventually, you're going to find yourself in a science class where you're expected to know this stuff. Okay, so if we were in person, I would tell you that you need to have memorized from tera to pico. Okay, now angstroms would not normally be on this list, but I like this list. I found it on Google. But angstroms are a useful one because that's actually what we use commonly to measure the distances between atoms. Okay, but here we have our metric prefixes. The most common ones that we'll deal with are centi, milli, nano, micro, kilo. Right? Those are the most common. Right? But the rest are totally fair game. Now, the easiest way to deal with keeping things straight on this table, right? So whatever your base quantity is, so we just listed all those SI common base units. So whatever your base unit is, put that in the table. So if I want to find out how many, let's say, milligrams there are in a gram, right? So I'm going to change colors here just because it's fun. So we're talking about milligrams to grams. Okay, so what I'm going to do is I'm going to put grams, so milligrams is 10 to the minus 3 grams. Okay, if I want to know how many kilometers there are in a certain number of meters, right here, I'm going to say kilometer is 10 to the 3 meters. Okay, and you always put the 1 with your multiplier. Okay, so 1 milligram is 10 to the minus 3 grams. 1 kilometer is 10 to the 3 meters. Okay, so it's a useful way to go about using this table, right? Because we're going to be using these relationships a whole bunch. Okay? And how we're going to be doing that is with a thing called dimensional analysis. Okay? Essentially, doing unit conversions. Unit conversions. It's a really common thing. If I need to go from milliseconds to seconds, or if I need to go from pounds to kilograms, that's what we're going to be doing. So with this table, we've got all these lovely relationships. Okay? So with this table, we just did this example with 1 kilogram is 10 to the 3 grams, right? And so I can write that as a ratio because they're equal. So I can write that as 1 kg over 10 to the 3 grams, or 10 to the 3 grams over 1 kg. Okay, both of those mean the same thing because it's an equality. They're equal to each other. So the ratio doesn't mess anything up, right? And what we're going to be doing is using this to convert between units. Right, so let's take a look at a problem and see how this is going to work out. So here's our question. How many grams are there in 56 megagrams? Right, so if we come up to our table here, so we're going to be looking at mega. So 1 megagram is 10 to the 6 grams. And I can write that as a ratio. So 1 megagram, 10 to the 6 grams, or 10 to the 6 grams in 1 megagram. Right, so our strategy here for all of these types of problems, and I want to make it very, very clear, you do not have to use algebra. And I'm going to say that again. What I'm about to show you is applicable for nearly every single problem that you will do all semester long, and you don't have to use algebra. Okay, this technique that we're going to be doing applies for everything. Okay, so you don't have to try multiple ways to do things, trying to make it simple on all of you. So your strategy. Start with a known quantity. right? In this case, our known quantity is 56 megagrams. Then we're going to apply a conversion factor and cancel units. Right? So in this case, I'm talking about our conversion factors are these relationships written as ratios. Okay, so here's our strategy. I'm going to start with my known quantity, 56 megagrams, and I want to use one of these equalities above to put the thing that I'm canceling on the bottom. I want to get rid of the megagrams. Okay, so I'm going to write a ratio that puts the megagrams on the bottom. All right, and so just like dealing with fractions and ratios, guess what happens? These units cancel each other out. So what I'm left with will be a unit in grams. So I'll end up with 56 times 10 to the 6 grams. Right? Which equals 56 million grams. Right? So the important thing is start with your known quantity and then use a conversion factor that puts the quantity that you want to get rid of on the bottom. Right? Let's do a couple of more examples of that. So here's our question. How many centimeters are in 25 kilometers? Right now, if I'm clever, I can do this in one step, but I don't have to. Okay, coming up here to our table, there's nothing in here that that goes straight from kilometers to centimeters. Okay, so all these relationships are to a base unit, so kilometers to meters or centimeters to meters. So I can approach this problem the same way and just do it in 2 steps. Right, so I can go from kilometers, so 1 kilometer is 10 to the 3 meters, and I can say 1 centimeter is 10 to the minus 2 meters. So I can do this in 2 steps. So let's show how to do that. All right, so 1 kilometer is 10 to the 3 meters. And 1 centimeter is 10 to the minus 2 meters. Right, so I'm going to start with my known quantity. Right, and I'm going to take this and write it as a conversion factor that puts kilometers on the bottom. Because I want to get rid of the kilometers, and my relationship with kilometers is through meters. So 10 to the 3 meters is 1 kilometer. Right? So if I stopped here, I would have an answer in meters. My kilometers would cancel out, and it would say 25 times 10 to the 3, and there we go. Okay? So, but I eventually want to get to centimeters. So I'm going to do another conversion that puts now meters on the bottom, because meters is what I want to get rid of. So I have 1 centimeter over 10 to the minus 2 meters. So that'll be my next step. Right? So the same thing happens. So in my first step, I got to meters. Now I'm putting meters on the bottom, so meters cancel out, which leaves me with centimeters. So putting this into the calculator, essentially what you're going to enter is 25 times 10 to the 3. So if it's on top in the ratio, you multiply, and then divided by 10 to the minus 2. If it's on the bottom of the ratio, you divide. Okay? So our final answer would come out to be 25 times 10 to the 5 centimeters. All right, let's do one more of these unit conversion type problems, one that is not quite as straightforward because it's not necessarily metric, but I want to illustrate that this can be applied to just about anything. So our question here, how many feet in 194 centimeters? Okay, so let's say you meet somebody from Europe who does everything in metric, and you ask them how tall they are, and they say, I'm 194 centimeters. Not likely, they're probably going to say 1.9 meters, but let's say they did. So we need relationships that will get us from feet to meters. Or excuse me, between feet and centimeters. Right? So our relationships are 1 foot equals 12 inches. And then 1 inch is exactly 2.54 centimeters. Okay, so let's start with our given information, 194 centimeters. And I want to get rid of the centimeters and eventually get to the feet. Okay, so my relationship that has the centimeters in it is my relationship to inches. Okay, so I'm going to put the centimeters on the bottom, because that's the part that I want to get rid of, to 1 inch. All right, so my centimeters will cancel out, so if I stopped here, I would have an answer in inches. So now I'm going to use a second conversion factor to get me from inches to feet. And I want to put inches on the bottom, because that's what I want to get rid of. Okay, so if I'm putting this into your calculator, what you would actually enter is 194 divided by 2.54, divided by 12. So our answer should come out to be 6.36 feet. All right, I'm going to go ahead and stop this video right here, and we'll pick it up next with talking about derived units.